Hello students, आज today we will learn the parabola. This is we are writing this videos for the people for those are preparing for the JEE examinations, mains and advanced, so that they will understand the complete parabola. We will teach you the complete parabola in this lecture. So in this complete parabola, you will learn in this lecture is there for the JEE examinations. Every formulas you will learn here. Look on the figure. This is the parabola, the graph of the parabola y square equal to 4ax. Here we have a x-axis, and you see this is a y-axis are there. I will show you. This is a x-axis, and this is a y-axis is there. And I sketch this curve. This is a curve is that you can see this is a curve. This curve is known as parabola. This curve is known as parabola. And this one is given to you. So this is a focus of this parabola. And this line, you are watching this one, this is a directrix of the parabola. At this point, O. So look out here, this is a y square equal to 4ax. This is a standard equation of parabola. What I say? Standard equation of parabola. This is the graph of this equation is there. You say in this equation, this graph is there. I say that here this is a parabola equations. It's representing this parabola. All right. Here x is always positive. You see this one in this parabola, this terms x is always positive because a is a positive term. I am taking this one a, small a is positive number. That's why you see this x is always a positive number is there. So we see the focus. The focus of this parabola will we can see a comma 0. A comma 0 is the focus of the parabola. This is a coordinate of the focus. That a comma 0. This is a coordinate of the focus. At this point, we say that here known as vertex. O is here known as vertex. And the coordinate of vertex is, you see, what is the coordinate of vertex? 0, 0. 0, 0 is the coordinates of vertex. We are writing this coordinates in terms of, x, y, x followed by y. And here, you see, this is a directrix are there. And this equation of this directrix is what? Is already given here, x equal to minus a. This is the equation of the directrix. It's given here in this question. Now, let's say we take a point P on this parabola is there. P is a point on the parabola. We say P is a point on the parabola. And its coordinate we say x, y. Okay. And we say its coordinate is x, y. In the Cartesian coordinate. But usually we write down the coordinates in the terms of, in the case of parabola, like say we use the coordinates at square, comma 2at. Usually what I say, I will write down the parabola equations in terms of this way, that at square equal to 2at. So at square comma 280, this is the equations are that we are usually using the parameters equation. Instead of xy, we usually use the at square 280 as a coordinate of the parabola, where t is a parametric in parametric form. T is a parametric parameter. T is a parametric parameter. So what is the value of t? You say that here if you compare these two things, this is x, this is 80 square. It means x equal to 80 square. And this is a y and this is 280. It means what? Y equal to 280. So the value of x and y is this one. We say x equal to 80 square and y equal to 280. But usually I write down use this expression to represent the coordinate of the parabola. So this we say that here x equal to 80 square, y equal to 280. Let's suppose you have a parabola. Equation is given to you y square equal to 8x. And now I would like to find out here the focus. Okay, the focus of this parabola will comes out. You say compare with the standard equation y square equal to 4ax. So you compare these two equations, this equation and this equation. You find 4a equal to 8. Implies that a equal to 2. So the coordinate of the focus, you can say 2 comma 0. Right. The coordinate of vertex will remain same, 0 comma 0. It will not change. Even in this case also, the vertex coordinates will remain same. Vertex is 0 comma 0. Okay. Now, what I want to say, the point. Let's say point P, and the coordinate of this point P is, we say that here 1 comma 2. Okay. So what is the value of T? In terms of 80 square and 280, how can you write down these terms? So 1 comma 2 is there, the coordinate of P equal to 1 comma 2. It means 80 square equal to 1 and 280 equal to 2. So value of A equal to 2 here. So what the value of T comes out? If we put the value of A here, so T will comes out T equal to what? 1 upon A, and that we say 1 upon 2. So T comes out 1 upon 2. So I represent this parameter as T, and the value of T equal to what? Half. So this is the way we are talking here, that the value of T will comes out half is there. T is the parameter. So you can calculate the value of T very easily. This 280 equal to 2 is given to you. So you put the value of A here, this A, and you are getting the value of T. So this is the parameter. This coordinate will be represented by T, T1, you can say better, T1, and the value of T1 is here half. So point can be represented on the parameters are there. I will draw the codes. Okay, let's say what is the meaning of this codes are there. Code, CHORD, code of parabola. So codes are there. I want to draw the codes are there. I can take any 2 points on the parabola and draw a line. Connecting these 2 points are there. These 2 points, I say there's this point and this point. These 2 points on the parabola are this line. This line is known as chord. And I say that this line has a chord is there. So I would like to write down the equation of this chord is there. Suppose a point T1 is given to you, and this point is T1, and this coordinate point is T2. The end points of the chord is given to you. The end points of the chord and points of the chord T1 and T2. These 2 points are given to you. And I have to write down the equation of this chord. What is the aim is that? Equation of chord. So this equation of chord will comes out T1 plus T2 times Y equal to twice X plus twice A T1 T2. This is the equation of the chord. If the 2 points are given, you can write down in terms of T, the equation of chord is there. T1 plus T2 Y equal to 2X plus twice A T1 T2. This chord, you have seen this one, this chord will pass through the parabola also. You see that here. This chord is passing through the focus. If the chord is passing through the focus is there, this chord is known as focal chord. Okay. If a chord passes through the focus, I will make it in the second slides. So what happens if the chord will passes through the focus? This is known as focal chord because it is passing through the focus. So it is known as focal chord. I see what is a focal chord is there. So equation you know very well, the same equation we have. But in this focal chord, the one thing is very important. There is a very important relationship between these two endpoints, T1 and this endpoints T2 is there. That T1, T2 equal to -1. So T1, T2 equal to -1 is there. It means if the T1 has a coordinate, if you represent that T1 and T2, these 2 points are there, then T1, T2 equal to -1 implies that what? T2 equal to minus of 1 upon T1. So if a coordinate of T1, I see the coordinate of T1 is a T1 square, AT square, comma 280. Okay. Then the coordinate of T2 will be what? T2 will be a upon T square, comma minus twice of AT. So to find out the coordinates, much easier, minus 2a upon T, not T, minus 2a upon T. So we say that here if you know the coordinate of 1 points, I can also find out the coordinate of the second point very easily, directly also. If the first coordinate has a AT square 280, then the second coordinate end point of the focal chord is a upon T square, comma minus 2a upon T, because T1, T2 equal to -1. So many times in the paper, you see the question is asking the one end of the focal chord is given to you and they're asking the second end of the focal chord. So that's very easy. The one end is AT square, comma 280. Then the second end coordinate will be a upon T square, comma minus 2a upon T. Now you see what do we mean by the double ordinate. Double ordinate means again a chord, but this is perpendicular to the axis of the parabola. This is known as double ordinate, and we say this angle is what? 90 degree. This is known as double ordinate. Fine. This is the end point of this double coordinates. So this is a vertical line. You see, double ordinate is here is a vertical line, and this is, you see, h dash is known as h dash. Basically, you can say double ordinate, axis of parabola. Axis of parabola. So what we are saying that here, this double ordinate is perpendicular to the axis of parabola. And say this is the vertical line. And this is the vertical line is there. Suppose coordinate is T1 here, and this coordinate T2 is here. So T1 and T2 is since T1 coordinate, if you take 80 square, comma 280. So T2 coordinate will be what? The T2 coordinate will be same 80 square. The value of x will be same since it is a vertical line. So it is also 80 square. And we say that this one is say 280 is there. Now this becomes what? Minus of 280 because these are practically you can say this T1 and T2. So T1 equal to what? Minus of T2. In case of not the minus of T2 is that because yeah, right. We are putting the value of T just T1 and minus T2. This two coordinates has some relation, same relationship. T1 and T2 has a relationship. The T1 equal to minus of T2 or vice versa. So you have seen this double ordinate is a one special type of chord that is perpendicular to the axis of parabola, and the both the side the T1 T2 has a very simple relationship that T1 equal to minus of T2. Now we will learn the next very important parameter that is a latus rectum. See, the latus rectum is a focal chord that is also double ordinate. You say this is a, let's say this one, it's passing through focus. Okay, it is passing through the focus and has an angle is 90 degree. Means focal chord as well as double ordinate. So this coordinate is T1. We say this coordinate T1 and this coordinate is T2. So this is a focal chord. Latus rectum is what? Number one, you can say it is a focal chord because it passed through the focus. Second, it is latus rectum is also a double ordinate because it is making it is perpendicular to the axis of parabola. Okay. Third one, we say this 2 point T1 T2. So T1 T2 equal to what? 1 and minus 1. You can say this plus 1 and this is minus 1. The value of coordinate T1 equal to 1 and T2 equal to minus 1. So value of T at you can say at this focal end point of the latus rectum is 1 and here minus 1. So the end point of this is very important. You say plus 1 T equal to 1 and T equal to minus 1. And the equation of this latus rectum, the length of this latus rectum will we can say T in terms of T's we are talking here. The length of latus rectum will be 4A. Length of latus rectum will be 4 times of A. So this one we are talking this length of this latus rectum from one end to the another end. I am asking the interested here this length from here to here. This will comes out 4E. The points is T1, T2. And what is the value of vertex in terms of T? The vertex at terms of T, it is comes out T equal to 0. So you see in these values, T equal to 0, at the end point of the latus rectum, we are getting a T equal to 1. And further, if you further move, that this point will comes out like say T equal to 2 and so on. So you see that here this T3 you can see, and the number is increasing. So again from here 0 and we are moving from here up to 1 and then we are moving towards 2 and then 3 and the value of parameter T increases as we move ahead. Now we have learned some parameters. Now I would like to run this parameters tangent, or before tangents, better I will learn this one diameter. Okay, diameter of parabola. Diameter, you have learned this word, the diameter in circles. Diameter of parabola. Usually, let's say what is the diameter of parabolas are there. You have a lines, you have just draw the chords, parallel chords. I draw this chord and I draw the another chords parallel to this line, and I draw the another lines parallel to these lines. So basically we are drawing the some parallel lines. You see this parallel lines. We draw the parallel chords. Say this is a what we are doing here. These are the parallel chord. Okay. You can say this. These are the parallel chord one. These chords are there. All right. Now you see what is the slope of this parallel chord. The slope of parallel chord. The slope of parallel chords is less than 90 degree. You see this angle. This angle is less than 90 degree. The slope of all these parallel chords are same because they are the parallel lines. The parallel lines have the same slope, and this slope is less than 90 degree. I repeat, this slope is m. Okay. Let assume slope is small m. All right. Now I take the midpoint of these lines. See, so this midpoint will comes out above the x-axis because the slope is less than 90 degree. If slope equal to 90 degree, the midpoint will comes on the x-axis. If slope is more than 90 degree but less than 180 degree, then it will the midpoint will comes below the x-axis. So I say the midpoint is coming here, somewhere here. So I take the midpoint of all these lines. I draw a line connecting the midpoints of all these points are there. This line I highlighted is the diameter of the parabola. This highlighted line is known as the diameter of the parabola. So what is the equation of this diameter of the parabola? It basically bisects the parallel chords. Diameter is the line. This is a midpoint of all the lines. Diameter bisects the parallel chords. I write down here the one more step. Diameter bisects means divide in two parts. Bisect the parallel chord. These all parallel chords are bisected by this diameter. Means this line, this distance, and this point segments are equal. This segments and this segments are equal. You see double lines better. You make it. These triple lines are equal. So it is divided. This is the midpoint. You can see these are the midpoint. So diameter bisect the parallel chords. Or we say what is the equation of the diameter? We are interested here. The equation of diameter is there. The equation of diameter will be x equal to say this is a horizontal line. So naturally this horizontal line, the value of y is constant. So y equal to, here we can say y equal to 2a by m. All right. Y equal to, we say 2a by m. This is the equation of this diameter of the parabola. Y equal to 2a by m. So it depends on the slope. Slope is positive, the value will comes out above the x-axis. If the slope is negative, then it will be comes out downside. I will draw you another lines and show you the another example of this parabola. Suppose our parallel chords are like this way. We are having these lines this way. Parallel lines, no doubt, on the parabola. All right. Now you see this in this case the slope is what? This slope is more than 90 degree. In this case the slope is more than 90 degree. All right. And so where we have to draw the diameter of the parabola. So the midpoint will be now below the x-axis. You see this is the midpoint of these lines will be below the x-axis. If you draw the diameter of the parabola, you see this is a diameter of the parabola. This is known as, you can say, diameter of parabola. And the equation is what? The equation of this diameter of parabola is y equal to 2a by m. Say now the m equal to what? Say m is more than, the angle is more than 90 degrees, m is negative. The angle of inclination is more than 90 degrees. Angle of inclination is more than 90 degrees. So slope is negative. Slope is less than 0. If the angle of inclination is less than 90 degree, then the slope is positive. So here we understand this one thing, this the value of m is positive and negative. M is positive, m is negative. When the angle of inclination is lie in the range of 0 to 90 degree, or when 90 degree to 180 degree, it is negative, because we know m equal to tan alpha. So you have seen this angle of diameters are there. So it basically this diameter intersect this lines you see at this point at the parabola. So you draw the tangent at this point. If I draw a tangent at this point, the slope of this tangent will be also equal to the slope of the parallel chords. Now we talk about the tangent. Tangent is a very important terms in the coordinate sections or coordinates are there. Let's say we have any points and tangent will touch the curve at only one point. What I say? Tangent will touch the curve at only one point. So I would like to draw a tangent. It should touch only at one point only, not more than one point. Okay. This tangent we draw. We say this is a tangent, and this is known as what I say point P. This is point of contact. Point of contact. Because tangent touch the parabola at one point only. Tangent touch the parabola at one point only. One point only. So This is a tangent, all right. And I would like to write down the equation of this tangent to the parabola. What is the equation of this tangent is that we will, this is a straight line. And what is the equation of this tangent? Equation of tangent. Parabola is given to you. What is the parabola is given to you? The parabola is y square equal to 4ax. You see this parabola. For this standard parabola, and say what is the tangent equation will come out. Let's say this y square is there. Okay. And point of contacts, we say that here x1 comma y1. Okay. x1 comma y1. So this equation will comes out. Y is there, and this point of contact is y1. So y into y1. Square is there. We say 4a is there. Okay, 4a is there. Not 4a will be divided into a. X plus x1. This is the equation of tangent. In parametric terms, because we use the mostly parametric terms as in terms of t, instead of point xy, x1, y1, we say the t is the coordinate. So t is there. So in the terms of t, it can be written as t times t equal to ty equal to, we say, x plus at square. This is the equation of tangent in terms of parameter. Usually we use both the equations are there frequently. So not to worry, both are simple. T into y equal to x plus at square. Say in terms of t, you know the coordinate will be at square comma 280. We may write down this point coordinate as like this way, at square comma 280. So this at square same. T into y equal to x plus at square. These are the expression of the tangent, equation of tangent to the parabola y square equal to 4ax. So this tangent touches this point. You see that here at this point here, directrix at this point. So let me see express you extra things. What is the meaning of that? See, this is a tangent, and this is a tangent. Okay, we see it's a tangent, and this tangent meets the y-axis at this point. You see this point. This is matching the directrix. This is a directrix. And this directrix and tangent meets at this point. We see this point name is K. Okay. This point K is there. And now you know this is a focus of the parabola. And say this is a point of contact. P is a point of contact. So what I say here, P is a point of contact. P is point of contact. Point of contact. F is focus of parabola. And we say this is a tangent equation. And K is the point where tangent meets directrix. Point where tangent meets directrix. So this is a point K. So let's say what is the angle? Basically, this important thing is that this angle is very important when we are talking about this angle. If you say this angle, this, or you say this angle is always 90 degree. So this tangents, where this tangent meets this angle PFK is always 90 degree. So this is one of the important result that this tangent meets the directrix. No doubt, all tangent meet the directrix are there, and this is the focus, this point, and this one is making the angle 90 degree. So you can say this angle is 90 degree. So we say that here, just you see this one, this angle comes out. One of the important point of this tangent comes out. This angle is 90 degree. So what I will want to say here, this tangent at the end point of this lateral rectum, they are making the meeting the directrix are there. So suppose what will happen if you draw another tangent from this point to this directrix are there. You will find that angle will be all right. Now we are talking about the normal equation of normals. Equation of normal. First, look out here. What is a normal? Let's say you have a tangent at any point. I will draw a tangent. We say this is a tangent, and this is the point of contact P. And at this point of contact P, I draw perpendicular to this tangent a line. We draw a line that is perpendicular to this tangent. Okay. So these two lines, tangent and normals, are perpendicular to each other. Always remember, the tangent and normals are always perpendicular to each other. So this tangent and this is a normal is there. So I would like to write down this equation of this normal. Point P is given to us. Let's say this point P, the coordinate of this point P is given to us, and we say the coordinate is x1, comma y1. Equation of normal to the parabola y square equal to 4ax at point P x1, comma y1. So what is the equation will comes out? Two equation will comes out, one in the parametric forms and one in this terms of x is there. So we write down here the equation in terms of first parametric forms. Y equal to minus of tx plus 280 plus atq in the form of parametric. I can write down this equation of normal. Similarly, I can write down the equation of normal in terms of another form is there. Point is what? P x1 y1. We better write down the terms. Points are 80 square comma 280. Point you can say 80 square comma 280. Point is that. Now, I also write down the equation of normal in the another way also. Y equal to, we say the slope of this normal is small m. In terms of small m, the slope of normal is m. So we write down the equation of in this way also. Y equal to mx minus twice am minus amq. This is another form of the equation of normal is there, where m is slope of the normal, slope of the normal. The slope of the normal is this one. We say y equal to this one is the slope of the normal. And at which point? And normal at the point is, and the point of normal point is that here, not the this 80 square 280. The point is am square comma minus 2am. The point is different. You see this one is not the 80 square 280. This one is am square minus 2am. This is a point of you can say contact, where we are drawing the normal am square minus twice am. Remember always this is a point, and here we are writing this equation m. For this point 80 square 280, you are writing this normal equation. For this point am square comma minus 2am, we are writing this equation of normal, where m is the slope of the normal. So remember always the points coordinate of the point is not same. Here is a 280 plus, and here is a minus of twice of am. Now let's say here again I am drawing a tangent. This is a tangent. I draw a tangent. This is what? Tangent. I draw tangent. Okay. Now I draw this point of contact P. P is the point of contact, and I draw normal at this point of contact. Okay. This is the equation of normal. This we say this is a normal. Normal. All right. You say this one is tangent and one is normal is there, and another one is the x-axis. You say this one is x-axis. So this tangent intersect at the x-axis. At we say the point is T. Okay. I say tangent intersect x-axis at point T. Similarly, the normal, this normal is there. I say it intersect this x-axis at n. Normal intersect this x-axis at point n. All right. Here you see this one. F is a focus here. I will draw a line making this also focus line here. You see what is the thing? What is the important things are there here? I want to say this distance ft. I see the distance. This distance ft equal to we have a marker and put the different color. ft equal to fn. These distance are equal. ft equal to fn, and also these things are equal to what? fp. I will show you the FP is that marker. So I'm taking the marker with the another color. Okay, not the blue color. We are only using. So I take the gray color. You see this one. These three distances are equal. Surprising, but it's true that these three distances are equal. So suppose at this point of P, we draw tangents and we draw normal. They meet the x-axis at T and N. We have a focus that also lie on the x-axis. So we see this distance Ft, this distance Fn, and this distance Fp are equal. And this you can also find out very easily what is the distance of this one. P, the coordinates you know very well, 80 square, comma, twice of 80. If you find out the distance by using the distance formula, this will comes out a times 1 plus t square. And the distance is also a constant. We see that here this is a times 1 plus t square. So this is a very interesting picture we have got here. Now let's say I would write down a general equation of tangent. General equation of tangent. Equation of tangent. For example, I say y equal to mx plus c. This is an equation of line. And this equation of line is a tangent of the y equal to mx plus c is tangent of parabola y square equal to 4x if and only if c equal to what we say a square a by m, c equal to a by m. This is the condition. This is a equation of a general equation of a line is a tangent to the parabola. If the value of c equal to a by m. So I say that here this c equal to a by m is there. So we see the general equation will comes out y equal to mx plus a by m. We see this is a general equation of tangent. Means you can write down this equation. We can say this is the equation of a tangent to the parabola, and we can find out only the slope of the parabola, small m, where small m is what? Small m is slope of the tangent. M is slope of tangent. So you can say that this is a straight line y equal to mx plus c. This will be the tangent of this parabola. Only in this condition, if c equal to a by m, then you can say it will touch this parabola at one point only. For this one, the value of c must be equal to a by m. Let's say suppose you have a tangent, and you know this one point of the tangent is known to you. And we have another tangents. Let this point is T1 and this point is T2. Okay. And we have a two normals. Let we have two normals. Two normals. One at T1, two normals at T1 and T2. Okay. At this point of this parabola, we have two normals are there, T1 and T2. And these two normals meet each other again at the parabola. There is a condition. Suppose you have a two normals, they are lies on this, you draw the parabolas are there. They will meet the parabola again. These normals meet these normals meet each other at parabola if and only if T1 T2 equal to 2. So they are meeting at this, you see these points in the parabola. They are meeting these two parabola meet at the same point on the parabola. The condition is that they will meet only in this case when their coordinates T1 and T2 is equal to 2. Otherwise, they will not meet. They will meet each other at the same point on the parabola. Naturally, they will meet somewhere. They meet outside the parabola also. If T1 T2 is not equal to 2, they will not meet at the parabola. I see that one. In this case, you see this one, you draw some another normals, they will meet outside the parabola. Or you draw another parabolas like say this one, lines. You see here T3 is there, coming this one. Right. And you see that here. I draw the one more normals at the point T3. And you see this T1 and T3 is not meeting at the parabola. Because this product T1, T3 is not equal to 2. So they will intersect anywhere. Similarly, you can say T2 and T3, they are intersecting at this point. And again, you say that here T2 and T3 is also not equal to 2. So that's why they are not intersecting at the parabola. But if T1 and T2, the value is equal to 2, they will meet each other at the curve of the parabola. Let's suppose we again draw normal at point T1. Okay. This is a normal at this point T1. Okay. So what is the value of this another point T2 is that where it is meeting the normal parabola. T1, we say T1 is there and T2 is there. We draw, we have a normal. We have a normal at T1. Okay. All right. And this normal meets the parabola. Normal meets the parabola at point T2. Okay. So what is the coordinate of the T2? And what is the relationship between the T2 and T1? So you can find out the coordinate of this point T2. T2 will be equal to what? Minus of T1 minus of 2 upon T1. So we see that here T2 will be equal to what? Minus of T1 minus of 2 upon T1. So you know this is a normal meets the parabola at point T2. Suppose let's suppose we have a 3 points on this parabola. Any 3 points we have on this parabolas are there. All right. I just take the and this point, better to easy one, this point, and I say take here this point. We have a 3 points on the parabola. You can take any 3 points on the parabola and connect them. So what I say, P1, P2, P3, P1, P2, P3, P1, P2, P3 are any 3 points on the parabola y square equal to 4ax. Okay. And now I find out the area between these 3 points. They are forming a triangle. So this is the area they are making. The area, I say the area they have, we say the area they have is delta 1. This triangle has the area is delta 1. Now, I would like to draw the tangents on these 3 points. And one tangents are here, and we are drawing the one tangents, this one, and I would like to draw the another tangents. So I draw the tangents also, and these tangents meets each other, intersect each other at these 3 points. Now, we draw the tangents at these points. Draw the tangents at point P1, P2, and P3. So we draw these tangents are there. They intersect each other and forming a area. And they are forming the areas are there. You see this one area. Make a triangle. They intersect each other at 3 points and forming an area. And this area we say delta 2. Okay. So the area, what is the relationship between the area of delta 1 and delta 2? So they intersect at the point A, B, C. You can say A point, B point, and C point. And the area of the triangle ABC, area of triangle ABC equal to half the area of this one, half the area of P1, P2, triangle P1, P2, P3. Means delta 2 is equal to what? Half of delta 1. So this is another concept that we will use in the parabolas. Let's say we want to know this one, what is a co-normal points? Co-normal points of parabola. Co-normal points of the parabola is a very important thing. Is that I say that here I just making this 3 points are there. You can show it. These 3 co-normal points are there. If we draw the normal on these 3 points, they are concurrent. Co-normal points of parabola. Let's say we have a 3 points. I say here P1, and this P2 and point P3. If we draw the normals, they are concurrent. Let's say I will draw the normal here at this point, normal at this point, and I would like to draw the normal at this point also. These three normals are concurrent. Co-normal points of parabola, three normals are concurrent. It means they are passing through a single point. You see that here. Here, this point is that this point is common to in this all these three normals are there. So we have a draw the three normals. We see normal number one, normal number two, with this two better, normal number one, and normal number three. I draw the three normals at the parabola, and all these three normals meet at the same points. So these 3 points are known as co-normal points of the parabola. They are P1, P2, P3 are known as co-normal points of the parabola because these three normals are concurrent. They meet at the same point. Always remember, always they meet at the x-axis because y1 plus y2 plus y3 equal to 0. Not naturally it meet at the y-axis, they can meet at any point. They can here I'm showing this one meeting in the y-axis is there, but they can meet at any point. Condition is what? For the co-normal points of the parabola, condition is that their ordinates y1 plus y2 plus y3 must be equal to 0. One condition. For co-normal points of the parabola, this condition must satisfied y1 plus y2 plus y3 equal to 0. Means ordinate of these points. You can say here x1, y1. The point coordinate of P2, you can say x2, y2. And this coordinate of P3, you can say x3, y3. The ordinate y1, y2, y3, the sum of the ordinate must be 0. Second, normal. And we see the slope of the normals, m1 plus m2 plus m3. The slope of the normal must be equal to 0. These two conditions must be satisfied to make the points co-normal. Otherwise, points are not co-normal. The points are co-normal only in this case when these two conditions are satisfied. Say the slope of this line, normal n1, n2, and n3 must be equal to 0, where m1, m2, m3 are the slope of the normal n1, n2, n3. These two conditions satisfied, then we say the point is co-normal points of the parabola. Or in the question, it is given to you that the points are co-normal points of the parabola. Then you can say y1 plus y2 plus y3 equal to 0, m1 plus m2 plus m3 equal to 0. Since you see this one y1 plus y2 plus y3 equal to 0, it means what? If we are forming a triangle, these 3 points are forming a triangle is there, P1, P2, P3. If I say these points are forming a triangle, if these 3 points are forming a triangle, P1, P2, P3, just we have find out different color pattern. Suppose these 3 points is forming a triangle, P1, P2, P3. The centroid of this triangle, G, must lie on the x-axis. The thing is that the centroid of this triangle will be lies on the x-axis, because y1 plus y2 plus y3 equals 0. So the centroid will lie on the x-axis. So we see the centroid. G is here what? Centroid. Centroid of triangle. The centroid of the triangle will lie on the x-axis. For if you making a triangle of P1, P2, P3, these conormal points are forming a triangle, then their centroid lies on the x-axis. Now, I see that here I will draw a focal chord. Any focal chord you can draw. What I say that I say this PQ. PQ is a focal chord. PQ. We take any focal chord. And I would like to draw this, taking this focal chord as a diameter. I draw a circle. Okay, I am not drawing a very good circle. But remember always, this circle will always touch the directrix. If you draw, a focal chord, if you draw a circle, taking focal chord as diameter, chord as diameter, and focus as center, you will find that it will always touch the directrix. The circle will always touch the directrix. The circle will always touch the directrix. Now it is touching the directrix is other. This is a directrix. So this circle is always touching the directrix are there. So we see that here these points are there. If you draw the, in the another words, let me explain you again. If I draw a tangents from the any point on the focus, let's say this is a focal chord. First to draw the focal chords, we see P and Q are focal chord. P and Q is the focal chord. Okay. For this focal chord, I draw a tangents. The end point of a tangents, we draw the tangents. And also I will draw tangents here. Okay. If I draw the tangents at the end points of the focal chord, they will always meet at the directrix. If we draw tangents at the end points of focal chord, they meet at the directrix. This is something interesting, that we have a focal chord. And the endpoint of the focal chord, these are the endpoint of the focal chord P and Q. And I am drawing the tangents, tangent T1 and tangent T2. And you see these tangents are there. Important thing is that these two tangents meet each other at the directrix. This is the point at the directrix they are meeting. And second most important thing is that the angle between these two tangent is here 90 degree. They are perpendicular. Means also these two tangents are perpendicular. Not only they meet at the directrix. The second important thing parameter, number one, they meet at the directrix, and number two, they are perpendicular to each other. They are perpendicular to each other. These is the very important factors are there that we are talking. This one, they are perpendicular to each other also. Now we will learn the equation of chord of contacts. Chord of contacts. It is similar to the like say circle, hyperbola, and parabola. In all the three cases, the equation will comes out in the similar line. The chord of contacts, when I'm talking this chord of contacts, what is the meaning of this chord of contacts? Let's say suppose we have a 1 point and we draw the tangents on the parabola. So we draw the another tangents. So this is the external point P, and its coordinate is x1 comma y1, and we draw the two tangents. We see tangent T1 and tangent T2 on the parabola. So these two tangents are meeting. They have a point of contacts, and these points of contacts we are having another one equation of chord. You say this is the chord of contact. I highlighted this one. This is a chord of contact. Chord of contact. Because it is connecting this point, contact point. This is a point of contact. These 2 points of contacts of this tangent T1 and T2, it's connected. And we want to write down the equation of this chord of contact. So chord of contact equation will be same. That we know that here T equal to 0. And what is the equation of tangent? You know very well. For the parabola, this parabola is that here y square equal to 4ax. This parabola, we see the standard equation is what? Y1 minus 4 times 2 times 2a. I will write down the clearly 2a, not overwriting. Y1 minus 2a x plus x1 equal to 0. The same tangent equations, or we are using the same formulas are there for the equations are there. Similarly, I can say that here I would like to write down the equation of this pair of tangents. Pair of tangents means here, let's take the marker and show you the another one colors below. This is a pair of tangents T1 and T2. Okay. I would like to write down the equation of this pair of tangents. Equation of pair of tangents. Pair of tangents. Okay, this additional point x1 y1 is given to you, the pair of tangents from point x1 comma y1. The formula is also same in case of circle, ellipse, hyperbola, parabola. We have the same formulas are there. That what? Pair of coordinates s1 equal to t square. So what is the value of s1? S is here what we see, that s1 t square. This is a formula. We are using this formula for all the cases are there. What is s here? The equation of the curve. We say that here y square equal to 4x. So we say y square minus 4ax. S1 is what? The equation of the curve when the point is x1, y1. So y1 square minus 4a x1. Okay. Then we say what is the equation of tangent? Equal to equation of tangent will you know very well, y1 minus 2a x plus x1. Put this value in this equation. Y square minus 4ax multiplied by y1 square minus 4a x1 equal to t square y1 minus 2a x plus x1 whole square. This is the equation of pair of tangents drawn from a point x1 comma y1. Now we want to write down the equation of chord whose midpoint is given to us. Equation of chord whose midpoint x1 comma y1 is given. Let's say what is the meaning of this one. You have a chord, you have a draw chords are there. This is a chord. This is the endpoint A, and this is the endpoint, you can say B, and we say this is the midpoint M. And the coordinate of this midpoint M is given to you, x1 comma y1. And now I would like to write down the equation. So this equation will comes out the same equation that we are using the circles, hyperbola, parabola, or ellipse. In all the four cases, we are getting the same equation, that S equal to, we see that S1 equal to T. So we say that here S equal to T1, the equations are that. Or you say that here so we are stopping this parabola. I think I have covered all the important points on this chapter.